Okay, I'd like to introduce our next speaker, Manfred, who I've actually never actually met, which is so I'm really excited because I've heard quite a bit about him. Um, Manfred is presenting, by the way, he's from DEF CON 858 in San Diego, California. Manfred is presenting How I Learned to Stop Worrying and Love the Ban, the Arms Race in Online Gaming. This talk will go on over the evolution of cheats and anti-cheat countermeasures in online gaming. Real examples will be given from games like Ultima Online, World of Warcraft, Rift Online, and present-day games that showcase from the point of view of a for-profit game hacker and monetization strategies, obstacles, and the ongoing arms race in cheaters versus anti-cheat technologies. Present-day state-of-the-art cheat and anti-cheat tech will be discussed along with examples of consequences to end users, security, privacy, and what upcoming tech is on the horizon. Manfred started out by taking apart toasters and breaking things to find out how they work. Wow, this sounds so familiar. That curiosity moved him to client-server authorization online games and snowballed into a 20-plus year career operating in the dark alleys of shadow markets. Manfred has been in the trenches of hacking online games while building out a tool belt to keep an upper hand in the ever-changing cheat versus anti-cheat arms race. So everybody, I'd like you to welcome Manfred to the stage.
Well, that was a very nice and crazy intro. I'm sorry to rug pull you guys, but I'm here to actually sell timeshares. Is anybody interested in a timeshare?
Well, I lived in Florida, so I feel right at home.
Okay, let's see if this works. I have this crazy 2-laptop system set up because I like to see speaker notes and I like to see which slide is next. But yeah, I'm a big fan of the movie Doctor Strangelove. I am Manfred. This is DEF CON 32, and it's 3 o'clock Pacific time. How do I? There we go. Oop. All right, cool. It works. So today's agenda, we're going to talk about games, all types of games, online games, single-player games, multiplayer games, peer-to-peer games. We're going to talk about what makes online games special, why they are a big target for hackers and trolls and cheaters and everybody else. We'll talk about the economy in games, the multiplayer economy, what motivates exploits and hackers, or hackers to find exploits. And then there's a lot of cool stuff going on, the cheat, anti-cheat, anti-cheat arms race. Things are accelerating very fast. It used to be back in between, I'd say, 2000, 2010, it was the Wild West. You could tamper with the game clients any way you wanted, and the game client wouldn't care. Anti-cheat game client obfuscation techniques started coming into play around 2010, and things just got crazier and crazier since then, especially the past couple of years. And then if we have time, I'll go over like a couple of practical examples of like how you exploit an online economy for profit. So who's this guy up on stage? My online nickname is Manfred. I was named by a game master in a game called Ultima Online back in 1997. They didn't like the name I picked for myself, so they just gave me a random name. It was some random NPC name named Manfred that happened to be nearby. He's like, hey, you're going to be called Manfred from now on. Like most people in the cybersec space, I'm curiosity driven, and I typically break things. I blue screened a lot of laptops, I bricked a lot of laptops, bricked a lot of devices. Luckily, it's all been good. Nothing has been irreversible. And my specialty are things I like to do the most because I'm crazy. I like to look at custom protocols and obfuscated code and how games and process in general interact with the operating system and what you can like discern from that. Like, what's this game doing? Is it like trying to be malicious? Is it basically rootkit disguised as a game? Is it sending back home a bunch of sensitive information it shouldn't be sending? That actually happens more so than not. And I've learned all of this through my 20-year career in like exploiting online games. They used to be my full-time job. I'd wake up in the morning, install a new game if a new game was out, find an exploit in it, and then that evening I'd be selling stuff online. I'll kind of go into that later. But through that entire span, I've always had my security researcher hat, and I've been a security analyst. I've done other stuff outside of game hacking. And coming back to the title of the talk, I've been banned over 10,000 times from a lot of different games. And I'll chat about that. But first, what's a curiosity-driven hacker? An example of this was when I was 8. I had a Nintendo Entertainment System, and I had a lot of free time on my hands. That's like the formula for when things go wrong with hackers, is like when you have electronic gadgets and a lot of free time, bad stuff happens. So I discovered that if you take a Nintendo system and you take a fork and you short out some pins in that Nintendo system, you get like garbled graphics. I got lucky, and I was able to like short out some data pins on how the cartridge was talking to the CPU, and I was able to do like cool stuff like garble the graphics, get weird ass characters to appear. I was feeling like hacker Jesus himself. I was like, man, this is the tops. Can't I peaked at the age of 8. But I continued on shorting out different pins, and then I figured out what an electrical fire smells like. Kind of smells cool, but also it breaks stuff. So I was very sad because I didn't have a Nintendo for the rest of that summer, or for the rest of the year. But anyway, then I discovered online gaming. Before we go into online gaming, I want to share with you guys the typical DEF CON talk prep that I think a lot of people do at DEF CON is you Google something first. You Google what the statute of limitations for computer crimes is. Luckily, it's 5 years. So back to gaming things. My motivation mainly was for curiosity, like how does an online game work? What protocol does it use? Does it use HTTP? Is it encrypted? Is it using WebSockets? If it's not using HTTP protocols, is it using UDP, TCP? Are they using stuff off the shelf, or are they like hand drawing their own custom protocols? And then I made a discovery at the same time, and that is, can you guys hear me?
Yeah, you're
Yes.
fine.
Yeah,
Okay,
we
cool.
hear you fine.
Yeah, okay. It felt like I was lagging. At around the same time, I discovered that players like buying gold from other players, especially in the MMORPGs. Initially, game developers didn't sell gold or items directly to players, so I came in, swooped in, and I filled that unmet demand. So I created a business, a for-profit business of like going into games, farming items in gold or hacking items in gold, creating them out of thin air, and supplying them to other players in outside markets. At first, it started on eBay, and then it moved to Chinese reseller sites like IGE, EGPal, player auctions, and things like that. Activity in this is what's known as the shadow market, and the shadow market is pretty big. I'll get into that later. So what's an opportunity like for a game? For an example game, what can you profit off of it? So this is a recreation of an actual conversation I had with one of my wholesalers that was looking for gold. So I hit him up. I was like, hello, what are some hot games in demand? And this wholesaler said, Lord of the Rings Online is pretty good. Dark Age of Camelot is still pretty hot. And then the seller said they always need more Final Fantasy 14 gold. And then they asked me, can you do FIFA online? FIFA had this new system called FIFA Ultimate Team Points, I think. And I was like, I never looked into it. Is the demand pretty good? And they told me they can buy around $500,000 USD per day worth of FIFA coins. I was like, interesting. So I did some back channeling, cross-checked their thinking, and yeah, there was a huge demand for FIFA coins. I found out Electronic Arts was also selling FIFA coins to players directly for cash, and I didn't want to cross that boundary of interfering with Electronic Arts' business model. There's some people that did, and it's well documented. If you Google FIFA coin gold farmers, they made a lot of money very quickly. I think a few $1 million in the span of a few months. But FIFA has a very big legal team. These guys got found out, and it wasn't a very happy story in the end. So I'm glad I stayed away from competing with a game company and how they monetize their games. But a brief timeline. of my 20-year career in hacking online games for profit. Started off with Ultima Online. It ended off with Guild Wars 2 around 2017. And in red, here's the number of accounts that have been banned in each game. UO was around 100. Dark Age of Camelot was around 1,000 accounts that got banned. Also, Dark Age of Camelot, I used the same exact exploit for about 13 years before they discovered what was going on. Final Fantasy, around 500 accounts. Lineage, around 100. Final Fantasy 11, 500. Rift Online, they were very good at banning my accounts. I went through about maybe 50 accounts per day, lost 4,000 accounts there. Guild Wars 2, also very good at banning accounts, went through 20 to 80 accounts per day, lost about 4,000 accounts there. And then games like Shadowbane and WildStar, they never actually caught on. Maybe they didn't have any like monitoring tools on the back end to see if you had level 1 players with like 3 billion gold running around, or insane amounts that a player shouldn't have. And then this black dotted line happens to coincide with the statutes of limitations for computer crimes. So I'm just kidding. I never continued hacking games after I left that field in 2017. So let's set the stage a little bit. This should be pretty obvious to everybody, but we'll talk about like what are the different types of games and what are the pros and cons. So old school, you had single player local games. You played a game and the game state is saved typically to the file system on your disk, and it kind of like keeps track of like the world state and your character state. So when you open up the game, it reads the game state and you resume wherever you left off. There's problems with this because if you uninstall the game, you lose all your progress because the save file will probably get deleted. If you install the game on a different device, it's hard to transfer that progress, especially if you don't have like root on an Android or iOS device or some other device that's locked down. But more importantly, the state of your game save can be easily modified. Like you can just use a text editor and go in typically and give yourself all the gold points and items you want. So then came single player online games where the game state is stored online through some RPC call to a game server on the back end, and the game server keeps track and calculates your progress. This has some benefits. If you uninstall the game, your save data is typically preserved because it's tied typically to like some sort of account, or if you're using Apple ID or Google ID or Steam, it's tied to your identity there. If you install the game on a different device, your save state is loaded. Most importantly, it's difficult to directly edit the save state. So when you're playing a game that has scarcity built into the economy, like let's say you fight a really epic monster and it drops an epic sword, you can be pretty assured that no other player is going to have that sword. Therefore, it becomes a status symbol or what have you in that game, an item of envy, I guess, to other players. So when you get really cool stuff, you're happy because you're like, hey, this is something I earned, and I trust the game company not to give this item out to everybody, so it makes it more special for me because it's more rare. Single player online problems is you need an internet connection, but these days pretty much everybody has this, and you need to handle authentication, but that's also provided by third-party identity providers. Then you have multiplayer peer-to-peer. Grim Dawn is an example. There's a lot of different games that use this model. And it's basically each player is in charge of saving their own game state, and they share this game state with each other's game clients. It's a lot like the single-player model, local model, but the game state is shared between game clients. There's no server involved. So benefits with this is it's more fun to play games with friends, but you still have the problem of if you uninstall the game, you lose the progress, and if you transfer the game to a different device, you still lose the progress. And the save state can easily be modified. So your friend might be like, hey, what if I give myself superpowers or tons of gold, and then you log in to play with your friend, and you'll be like, hey, you're boosting. Like, there's no way I'm going to catch up to you because you were cheating. I don't want to cheat, stuff like that. So it creates conflicts and friction in the gameplay experience. Then my favorite is you have multiplayer online, where typically there's an authoritative server involved in pretty much every single action, every single player transmits to that server. So here in the very famous Ultima Online screenshot, where you have two friendly neighbors, player 1 and player 2 each have their own game clients, and they're talking to the game server, and the game server is keeping track of player 1's and player 2's game states. There again, if you're going to try and hack this, you have to reverse engineer the client, reverse engineer the RPC protocol and how the game client is talking to the server in order to modify, your gold or progression inside the game, which is difficult to do typically. So you had an increased illusion of scarcity and value for the items you earn inside that game. But again, if you uninstall the game, install on a different computer, your save state will transfer over. Again, you need an internet connection, authentication, but all that is typically handled by something else. But for the game developer, it gets more challenging because you need to build complicated systems to track the game state of a massively multiplayer game. Like some of these servers handle maybe 50,000 players, and they need to handle how items are spawned, how items are transferred to each players, how auction houses look like, in-game mail. Like some games allow you to mail items to other players, different auction mechanics, and there's always a developer to player cash store. Typically, game companies have to reinvent the wheel on all of this for every single game, and what that leads to is the same exploits found over and over again. So let's chat about game economies. There's two, at a super high level, there's two types. There's a game economy that's intended to be played as by the developer, like their vision of how the game should be played. And then there's what really takes place. And as we know, players are like a box of cats, and it's really hard herding cats. So in a MMORPG economy, you typically have what's known as faucets, things that generate items, and then you have drains, things that consume items. And in the mix, you have players. They interact with each through gameplay and other mechanics. So a way of getting a game inside, or a way of getting items inside the game, is to play the game. You kill stuff. You either farm resources and you get gear, resources like iron ore and stuff like that, or gold coins. The other way is to do an in-app purchase flow where you buy cosmetics, typically like a new hat, or quality of life things, like things that let you teleport to friends, or maybe let you get more XP more quickly. And these items can typically be traded with your friends inside the game. It's totally fine. But as soon as you try to sell those items for cash on some forum, like player auctions or eBay, that's known as RMT, real money trading, and you get banned for that. And that shadow market, or that real money transaction shadow market, is pretty big. The players interact with black market sales all the time. It's a multi-billion-dollar industry. For example, in Fortnite, people were transacting $1 billion worth of game accounts annually. And any game that allows player-to-player transfers is always going to have a black market. And then this is, like I said, against the terms of service. Typically, shadow market sites that you interact with will have in bold red on top of the site saying, hey, if you buy golden items through us, you risk getting banned. And even though that's widely known by players, they still participate in it because it's one way to avoid tedious tasks inside of the game that are a grind. Like in some games, you might have to grind for a couple of weeks to get an epic sword. Some players don't have the time to do that, so they'd rather go to some seller on the shadow site and pay a couple $100 to bypass all that work. So it's in huge demand. And popular items that are being traded, you have game currency, gear, and sometimes entire accounts. And the workflow for that, for a farmer or anybody that wants to supply the shadow market, is you log into the game, you gather items and gold, and you sell it to the players directly, or you sell it to resellers. So why do people exploit in games? Two obvious ones: for fun and profit, the old saying. For fun, typically you have things like wall hacking, radar views, anything that lets you get an advantage over another player, teleporting around, aim bots. If you're looking to earn some money, you can have a farming bot just play the game for you and amass tons and tons of items and that you can resell. Trolling, I'm a big fan of trolling, exploiting for trolling. As long as it's done responsibly, it can be pretty fun. And also a big part of it is exploiting online games is a huge technical challenge. You got to figure out how all this stuff works before you can break it, and that in itself is a game by itself. For profit, there's no shortage of sites trying to sell in-game gold in games like World of Warcraft. Pretty much any game that has trading, you'll have a site popping up there to sell you golden items from that game. Again, it's against the terms of service. You'll get banned for it, but it's still a huge industry. Then you have people selling services and tools in games. This is a screenshot of the site. I won't call out, but they basically have exploits for pretty much every single major game out there. They claim that their exploits are undetected because they use very crazy and advanced kernel level based exploits that kind of like live inside of the Windows operating system. So it's harder to detect using anti-cheat methods. Some of these sites, they make millions of dollars per month because they have thousands or tens of thousands of players spending $20 to $100 a month to get undetected cheats in their favorite game. So if you want to get into game hacking, you will need to build out a tool set. And this is a really big rabbit hole because typically you want tools that are not off the shelf. If you use off the shelf tools, you will get banned. Today's games, pretty much all of them use some sort of anti-cheat, and all the anti-cheat systems look for common tools like, hey, are you running IDA in the background? Are you running a hex editor that has memory access? Are you running a debugger? And things like that. And typically you'll get flagged and maybe kicked from the game with a friendly error saying, hey, you're running a program that's not supposed to be run alongside this game. Sometimes these anti-cheat things go a little wild. But sometimes I play games on my development system, and I had MySQL running in the background. And I tried to log into, I think the game was Star Wars: The Old Republic, and I logged in, and the game kicked me out and said, hey, you're running a banned program, and said the banned program was MySQL. I was like, that doesn't sound right, but okay, whatever. So when you're building out your tool set, you want to, your main goal is to somehow be able to modify the game client, get read-write memory access to its memory space. From there, you can build out pretty much anything you want. Like if you hook functions, you can modify your run speed. You can look at how the data is being sent between the game client and the game server to start fuzzing it. You can modify the game in any way you want as long as you have memory access. That's the hard part. To get there, you have to use tools to reverse engineer the game client while trying to avoid getting banned. Sometimes you'll have to sacrifice an account or a machine or a PC because sometimes these days when you get banned, your hardware ID of your PC will also get blacklisted. So like sometimes I have a throwaway PC or a VM machine that I do my initial recon on using tools like, x64 debug, Wireshark maybe, although that's not as useful in online games because most of them are encrypted and they use custom protocols. But it's a good way to get a quick lay of the land and see how the game client is talking to the server and how it's interacting with the operating system. See if there's any like ways you can like load a DLL into its process space easily through different vulnerabilities. Maybe get an idea of how the game client is trying to detect if you're using anti-cheat tools, if it's querying the operating system to be like, hey, enumerate every single process in this user's system, so I can like flag the ones that are blacklisted, and things like that. A good tool for this that's like a Swiss Army knife is called Cheat Engine. Highly recommend playing around with that. It's basically a debugger and a memory editor specifically built for workflows you do in like developing cheats in games, especially single player games, but it can also work on the online games. So the goal is to get memory access, but also to be undetectable, and that's very hard to do these days. I'll kind of go into that. So back in the day, you could run all of your cheat tools inside of Userland or Ring 3 in Windows, where you basically had your cheat tool, and for example, you could call Windows APIs to read and write process memory for the game client, and then that could get you a foothold into starting to tamper with that game client, reading values from memory, and then maybe potentially injecting some code to modify how the game works. This is pretty, it's out of all the options out there, this is like a lower learning curve. You could probably do a Userland-based cheat for a single-player game inside of a few hours, especially with the help of like ChatGPT or something. If you mess up, the game client will crash. Your computer won't blue screen, and it's well documented on how to pull this off in different communities and LLMs that have been fed with all this data. I'll link all this stuff at the end of the presentation. And it's likely to work with different OS versions because you're working at the application layer and you're not doing crazy exotic kernel land API calls. You're doing well-defined stuff that's going to be maintained between operating system versions. For example, some of the stuff I built in like 1997 just spins right up in the works in this year and on Windows 11, and I think I designed this stuff for Windows XP. So there's less maintenance and overhead to maintain your code. The only thing I had to do was make my code compile in x64 because all the games switched over to 64-bit, in the past 10 years. The problem with this is it's super easy to detect. I wouldn't recommend this method for anything other than maybe single-player games or games that that don't have anti-cheat present. An example of a Userland tool that I built over 20 years ago and still very relevant to this day. I still use it almost every day. So what's going on here is you have right. It basically injects a DLL into the game client. That is injected into the game client. It brings up a window. The top portion of the window shows you the packets that are going out of the client. And then to the bottom, and then send it. So that way, this is kind of like a burp suite for binary protocols. If you want to start modifying the subject protocol.
Review the computer game sounds crazy, right?
Okay, there we go. Is that better?
Yeah, thanks a lot.
Okay, so kind of what you see here is like me playing around and packets going in and out, and then I've discovered like what's it look like to move a item in your inventory using a packet, just to like validate everything is working correctly. Okay, I'll kind of skip forward. Okay, the next type of tools I started developing were kernel-based tools. because their userland stuff was getting detected, especially in like late 2000s. You had Warden, then you had Punkbuster, then a lot of the games built their own proprietary anti-cheat stuff. I think that's around the time Easy Anti-Cheat started coming out. So I had to move my tools into the kernel space or be a part of basically the Windows operating system. That gave me access to physical memory directly. It wasn't detected by any existing cheats, especially for the games I was targeting. It does have a steep learning curve. It took me, almost a year to transfer my tools and my knowledge and learn all about Windows internals. Used many undocumented features of Windows and Intel CPUs to help me do interesting things. So it has a very steep learning curve. You have to modify your kernel-based tools for every single version of the operating system. You'll have a lot of blue screens, and it's a big time sink. And then at the end, when you're done, you still have to sign your driver because Windows, especially since I think 2008, wouldn't allow you to load the driver unless it was signed by Microsoft. So you pay Microsoft and appear to be as a legitimate business saying, hey, I want to sign this driver because it lets me help with my business, or you exploit vulnerable drivers. And that's another deep rabbit hole. There's tons of vulnerable drivers you can exploit to gain basically read and write functionality to physical memory. And that way you can get a foothold to interact with the game clients. More recently, driver-based anti-cheat systems have detected all of this, so it's hit and miss. There's a lot out there that will not get detected by anti-cheat systems, and there's a lot out there that will get detected by anti-cheat systems, so it's a roll of the dice. Here, use that again. Here's an example of a tool that's in its second generation. I wrote the first generation completely in the Windows driver. Then I got together with a buddy of mine. We slapped a cool GUI on it and kind of rewrote everything to be more efficient. Basically, what this tool does is, whoops. What this tool does is it helps you examine what a game client is doing when it's executing based on user input. And what I mean by that is when you're reversing a game, most games are really big in size. They're between 20 and 100 megabytes. And when you disassemble that game, you might have 500,000 function calls you're going to be looking at. And it's really hard to find the functions that you're interested in. And when I'm reverse engineering binary protocols, I'm very interested in like how a game client is sending data out to the server, how that data is being encrypted, and how that data is being transported. To do that, you could do a bunch of like manual debugging with Olly debug or x64 debug. You could start at like a winsock send function and trace your array backwards. But then it gets really hairy because most games are multi-threaded, so the data gets shuffled around between different threads. And then you get lost really quickly in the rat's maze of function calls, call stacks, and where your data is at. So I created this tool to basically analyze the process as it's running. I feed it one input, that's a string of interest. And whenever the game client executes on the string, or whenever the string appears on the call stack for a function, this tool will pick it up. So this let me cut down my reverse engineering time from weeks and months using a traditional debugger method to a couple of hours, and helping me find a way to hook the network stack at the application layer, so that you can start fuzzing the protocol and finding exploits inside the game. So this is just an example of me going through it and then finding functions that process the string that said hello at whatever exclamation point. And then this way, you're able to find which functions you want to hook to examine data that's being sent out, and which functions you want to call to send mock or spoofed data out on to start fuzzing the protocol. My favorite, there's a lot of, so the anti-cheat cheat race is getting very hot. Drivers are being detected, and it's very difficult to build drivers that are stealthy now because all the anti-cheat typically lives at the operating system level now. So people are moving out of the Ring 0 operating system layer, and now they're doing hardware hacks basically to give you direct memory access to physical RAM. These are typically not detected by userland anti-cheats, and they weren't detected up until a few months ago by kernel mode anti-cheat systems. The way this works is you plug in a phony PCI device, and that PCI device has direct access to all your RAM. And then you connect the cable to it, and you basically pipe memory access to a different computer. So a second PC can be like, hey, malicious PCI device, give me physical memory belonging to this process, basically. So you have a 2 PC setup. One PC is a host for the dummy PCI card that gives you full memory access, and then you have a second PC that is able to issue commands and read memory. This has a steep learning curve. Again, it's OS version specific. It can be expensive. Some of these cards can go for hundreds, if not thousands of dollars. And they are also detected by anti-cheat systems. Currently, some kernel-based anti-cheat systems will detect this stuff. And again, you're playing with hardware, cables, different weird stuff going on here. So if you mess up in how you're using it, how you flash the phony PCI card, you might brick, a $400 PCI card, or you might brick your PC. So again, it's a big roll of the dice. But when you pull it off, it's pretty cool and worth it. It's a good hobby. So you have cheat software that's running on a separate PC now, and then you have your main PC that you're playing the game on. So another piece of hardware that's important is called an HDMI fuser, where you fuse the display of the second PC onto the main PC. So if you're building something like a radar hack or a wall hack where you're like outlining boxes around enemy players, you want to be able to overlay those things on your main gaming PC so you can see what's going on in the game as you're playing it, instead of looking over to a second monitor to see what's going on. PCI, or an HDMI fuser is undetectable. It's working at the HDMI level on the cable that's going out to your monitor, so there's nothing that can be done against that. There's companies that sell entire kits. They'll sell you the PCI direct memory access card, all the cabling, the HDMI fuser, and if you want to emulate the keyboard and mouse, you can get an emulator. I don't recommend this. It's a lot of money. And you will probably get banned, because in the games you'd want to use this in, especially competitive FPS games like Valorant and Call of Duty, the anti-cheat systems that are running on those will detect these things if they're not configured properly. Or even if they are, you still have to make sure to see if the anti-cheat systems are being updated to detect the current method of hardware cheat devices. So it's a very rapidly evolving cat and mouse game right now, and what your risk is getting an account banned and potentially getting your hardware banned. But again, it's a good hobby. Here's an example I found of somebody running this direct memory access cheat. On this screen on the left is the cheat computer that's analyzing physical memory from the gaming PC, and then it's able to extract data of where players are at, and then draw hitboxes around them. And then using an HDMI fuser, you overlay this to your main game, and then you can see exactly where the players are. And you get an unfair advantage. And I've never actually done this in practice because there's a couple of things wrong with this. Well, one, that's super cool and novel. It's bleeding edge technology. But two, most games, especially competitive shooters, use skill-based matchmaking. So if you're using this and you're completely dominating the playing field, what you're going to get paired with is other cheaters. And then everybody's on the same playing field. So the end result is, you're going to be playing with other players just as good as yourself, if they're using hacks or not. So it gets kind of interesting. So we have time. So let's go through and see what economic exploits look like and what a for-profit exploit lifecycle looks like. So when you want to hack a game, the life cycle or the workflow is you find a game that is going to be popular. If it's popular, it's going to generate more money for you. Then you reverse engineer this game, find the exploits. Once you find an exploit, you stockpile golden items inside of this game on your account. Then you transfer this account to a wholesale supplier that will resell out of your account to other players via some website or something. And then the exploit gets fixed. Typically, exploits live for, I'd say on average, most exploits before they get detected live for a few months. I've had exploits get fixed like the same day I discovered them, and I've had exploits live for about 13 years. And I've had everything in between. Once that happens, you either go through this same loop again to discover a new exploit. In my experience, every game has about 5 to 10 economic exploits that you can use to your advantage to mint infinite items and gold inside the game to resell to other players. Once that is exhausted, you find a new game or a new target. The exploit research itself, it's a big time sink. If it's your first day at the rodeo of exploiting games, expect to sink about 200 hours to get like a simple exploit, or not even an exploit, a simple tool set going that will help you discover exploits. So let me jump back really quick to a side story. This is an AI generated image of me basically, and I'm at Best Buy buying every single Final Fantasy 11 box they had. Final Fantasy 11 was a very popular MMORPG back in the day. And the way you bought those games back then is you get a box, and then inside the box there's a CD and like a CD key that you use to create an account. So I went to a Best Buy and I bought every single box they had. And the guy checking me out was like, "Hey, why are you buying so many? Do you own like a Game LAN, whatever workshop?" And I didn't know what to say, so I was like, "Nah, I get banned for profanity a lot, so I'm going through a lot of accounts." Kind of rolled his eyes, and I was like, "Oops, I shouldn't have said that." It was kind of cringe, but anyway, like I said, I was supplying Final Fantasy 11. They banned a lot of accounts, so I needed about 40 accounts per day, and the cost profit breakdown for this was back in the day, 1 million gold in this game was selling for $100. I could load up one account safely with 60 million gold without getting detected. So my per account profit was $8,000. A single box of Final Fantasy 11 cost $30, so my profit margin was close to 100%. So like what anybody else would do, I drove around in the LA area to every single Best Buy in the area, and I bought out every single Final Fantasy box they had. I'm sure Square Enix was like, "Why is our game so hot in this area?" Who knows? So let's kind of jump forward a little bit. So let's say you want to hack a game, you develop your tool set, you're going to attack the protocol. Again, the attack surface is either attack the IT infrastructure and you like get database root and modify your database that way. I wouldn't recommend that. That's highly illegal. I recommend for abusing functionality that the game server exposes to you. Typically, your game server has packet handlers or RPC handlers to handle things like logging in, logging out, moving, or one of my favorite exploits, I'll get into this in a little bit, is if you have something in your inventory and you delete it, there's a command you could issue to the server for that. And the server will process that command and modify your storage. For example, World of Warcraft had many commands that the game client sent to the server. I think it has close to 500 commands that the game client sends to the server, and about 600 commands that the server can send back to the game client. Most online games have more than 100 commands that you can start playing with and fuzzing. So let's go through a very simple exploit. This is one of my favorite exploits. This was present in actually a few games. Let's say you have 2 trash items in your inventory and you want to delete them. This is an example packet where it has an opcode saying, hey, this means delete this item. It has your character ID, it has your inventory ID or your container ID, it has the slot number, and then the quantity of how many of those items you want to delete. So if you want to delete this whole stack of green potions, you'd kind of send this packet and it would delete both potions and you'd have nothing left. But well, if you delete a very large negative number, when you take a negative and you subtract the negative from it, when you take a number and you subtract the negative from it, you end up adding to it. So if you try to delete a negative amount from your inventory, what will happen is it'll end up being added to your inventory. And this happened probably in 90% of the games I went after. Is you could delete something, give it a negative number, and then you just start minting that item out of thin air. For example, in Final Fantasy XI, I had stacks of 2 billion items in every single inventory slot, and I had like 60 inventory slots. So an insane amount. We're talking about insane numbers. My favorite type of exploit that's present in, again, almost every single game is a data race condition, because typically your game servers are distributed systems, and in distributed systems, data synchronization is a huge problem. And when you're developing a game and you're under the gun to push the game out on a launch schedule that the marketing team decided, you're going to avoid things like security issues with data synchronization in distributed systems. So this is very present in a lot of games. So let's say we're interacting with a game shop here and we're sending an opcode of 4. You have your character ID and we're issuing a buy command. You have the item ID, which happens to be a health potion, and you want to buy one of those. Great. Nothing fancy there. You're buying 1 potion. So what if you, instead of using a buy command, you do a sell command? And what would happen if you sent that sell command 2 times in a row in rapid succession? So what would happen is somewhere on the back end, 2 threads or 2 different processes would handle each packet separately. And then each one will go through its checks. It'll be like, hey, does this player have this item that they're trying to sell? And it'll be like, the first thread is going to be like, yes, they do. The second thread is going to be like, yes, they do. All right, cool. Increase their gold balance. Both of them do this. And then the first one tries to delete the item. It's like, all right, the item's gone. The second thread tries to delete the item. And it'll probably error out, but it'll error out gracefully. And then it'll be like, yeah, cool, the item's gone. I don't know what happened. There's some kind of error. Hopefully somebody will check it out someday. But in the end, as a player, you have 200 gold because you just sold the same item twice and abused a data race condition on the back end. Again, this was very common in Final Fantasy 11, 14, Guild Wars 2, pretty much every game I've ever touched. When I was preparing this talk, I was like, a friend of mine was like, are you going to mention Web3 at all? And the short answer is no, because Web3 gaming is a dumpster fire full of poop emojis. It's the quality of Web3 games isn't great, and they're mostly all made to be pyramid schemes to make money of unsuspecting people. AAA Web3 gaming might be a thing one day, but right now I'd stay away from it. So if I haven't scared you guys away or bored you to death and you want to dive into some game hacking stuff, I recommend these communities, Unknown Cheats, Guided Hacking, and Fearless Revolution. There's a bunch of people talking about anti-cheat, driver stuff, hardware stuff, anything you name. They go down very deep rabbit holes. Information sharing is challenging now because any information that gets shared publicly, especially on public forums, because people from Riot or Blizzard, Microsoft, they're watching these forums to make sure to be up to date on what's going on in the underground hacking scene. So a lot of the times when somebody finds like a novel way to bypass anti-cheat, they either won't post it or they'll post the results of it. They'll be like, "Hey, created this really cool thing that's undetectable." If somebody asks them to post the source code, they'll be like, "No," because they'll just get fixed by the game company because they're watching these forums. But it's a really good place to start, and there's a lot of overlap between game hacking, tool development, cheating, and all that, and malware development. Because malware development is all about staying stealthy and interacting with processes in a way that won't trigger either antivirus or other things from blocking it. Same thing with developing cheat tools. You're interacting with the game client, and then you have very advanced and sophisticated components looking at the interactions of that game client to make sure that nobody's interacting with it in a malicious way. So I recommend looking into Maldiv Academy. There's a lot of good information on operating systems, how virtual memory is laid out, threading, pretty much anything you want to know about when you're trying to develop tooling to help exploit video games. And of course, a book I highly recommend is Windows Internals. There's a few editions. I think the last edition covered Windows 10 or 8. It hasn't been updated in a while. I think the last edition was published in 2015, but it's very current on like what's going on in Windows internals right now. And again, I have a Twitter if anybody wants to hit me up for any questions. And I think that's all I have. So thank you very much.
Well, thank you. That was an excellent presentation. I actually have a question relating to VR that came out of gaming. We've noticed as we were looking into replacements for AltSpace VR that a number of the VR services out there, VR chat being one of them, essentially are using the same kinds of rootkits that games use in order to find cheaters.
Yep.
And we decided not to use those because we felt that people from DEF CON would probably be a little resistant to installing a rootkit on their machine just to watch a VR event.
I'm glad you used the word rootkit. I was going to bring that up, but I didn't want to stir a hornet's nest because it's a topic that's very controversial. Yes, anybody that is playing first-person shooter games that installs Vanguard anti-cheat or Easy anti-cheat are essentially installing rootkits. Especially they are very high priority loaded drivers that are like the first to load when the operating system boots. So they have a lot of power and a lot of access, and you're trusting the game company to either behave in a ethical way and not collect data on you, and you're trusting them not to get owned and then having a malicious driver get pushed out through their distribution channel. That's a lot of trust. I don't think anti-cheats should live on the operating system or on game clients. My solution to this whole problem would be to monitor player behavior on the server side and do things like skill-based matchmaking and other high-level analytics you could do without actually, peering into a user's operating system and see what they're doing. Because in my experience, when I was reverse engineering games, especially around 2010 to 2015 period, a lot of them were sending a lot of them were, phoning home with interesting data. Like they would send a process list back to the server, and that process list would have command line arguments because they wouldn't strip them down and things like that. Back then, that was pretty dangerous, but that is very dangerous now, especially if you have processes running with command line arguments that are very sensitive. One example would be like some Web3 stuff. If you have a wallet running and if you have some sort of private key or cryptographic secrets on the command line, which you shouldn't, but it happens. Those could be transmitted over the wire back to a game company, and who knows what analytics software that gets propagated to. So yeah, I agree that you guys shouldn't be using VR chat or anything that compromises privacy.
Great talk, Manfred. I always enjoyed listening to your presentations. Thank you so much for doing it in the DCG VR. Appreciate it.
Cool. Thank you very much, and I will step off now.